This is section 3, continuity, example 5. So, one of the 3 major theorems that you have to be able to cite on the AP exam. So you need to know the requirements for the theorem and then the result, okay, is the intermediate value theorem. It's used to prove that a point exists when a function is continuous on a closed interval, all right? So it says, and I'm just going to read it, let f be a function that is continuous on a closed interval from a to b, where f of a does not equal f of b. If n is any number between f of a and f of b, then there is at least one number c in the open interval from a to b, where f of c equals n. Now it sounds complicated, and it's actually very obvious, okay, the way that this works. If you look at figure 4, right here, n is that y value that we're talking about. This theorem essentially states that as long as you have a closed interval, which means that as long as it's continuous on a closed interval, you're going to hit every y value. That's it, right? That means that every point between A and B exists. That's it. So it's actually very simple. If you look at this figure 5, notice there's that open circle right here. And so because it's open, it doesn't follow that theorem, right? It's not a continuous function, so points can exist elsewhere. So that n value doesn't have to actually exist, even though it's between f of a and f of b. But that doesn't follow the theorem. Figure 4 is the theorem. And some real-world example, when you were a kid, at one point in your life, you were every height between whatever height you were born at and whatever height you are now. So no matter what, at some point you were 2 feet tall, right? Because 2 feet is somewhere between your birth height and your current height. Okay, you can't skip a height in between. You have to reach all of them, okay, based on your body. So that's essentially what it's saying. Now, this theorem only proves existence. It doesn't actually tell you what point it is. It just tells you it exists. And if the theorem doesn't hold, it says that the theorem doesn't hold. All right, it doesn't say that the point does not exist. It just doesn't prove existence, okay? So one way that we would use this is as in example 5 to show that there's a 0. Now remember, if it's a 0 or if it's a root, you'll often see the word root. So as root, that just means x equals 0. Y equals 0. Because remember, that's where it touches the x-axis between 1 and 2. Now the first thing you have to show is that f of x is continuous. Well, it's a polynomial, so f of x is continuous everywhere. So we can say f of x is continuous on the interval 1 to 2, which is all we're worried about. Now we need to find f of 1 and f of 2, and we do that just by plugging numbers in. So f of 1 is 1 plus 1 minus 2, which is just -1. And f of 2, we plug that in, we get 8 plus 4 minus 2, which is 8. Okay, so since, well, the other requirement is that f of 1 cannot equal f of 2, which is true, right? F of 1 does not equal f of 2, because -1 is not equal to 8. So now I can say that because f of 1, which is -1, is less than 0, which is less than 8, which is f of 2, by the intermediate value theorem, and you're allowed to abbreviate IVT. Everybody in the math world knows what that means. There exists a C value between 2 and 1 such that, ST means such that, f of C equals 0. And that's how you use it.